This is Geometry, Unit 8, Day 14. We're working from Section 11.5. This is page 758. We're working on the homework that deals with solving for the sector area. So for number 11, to find the sector area, we're going to take the divide by the area of the circle, pi r squared, and set that equal to the central angle over 360. Those ratios are equal. So we're looking for the sector area. The radius in this case is 10. The central angle is 60. You could reduce that if you wanted to, but we'll cross multiply so that the sector equals 100 pi times 60 divided by 360. So we'll bring in our calculator. We'll say 100 pi times 60 divided by 360 gives us this area of 5236. And we're not given a unit, except we are, it's inches. So this is going to be inches squared. For number 12, we're looking for the area of the shaded region. We know that our formula is always sector over pi r squared, the angle over 360. We're looking for the sector. The sector is our unknown. Here's our radius. So pi 14 squared. Now the angle. We have a degree value, and this 256 is all the way over here. And we need to have the angle value that is for the shaded region. All the way around is 360. So we're going to take 360 and subtract the 256. That's going to give us 104. So our central angle now is 104. So now we can cross multiply. The sector area equals 196 pi times 104 divided by 360. So we'll get our calculator and use 196 times the pi times 104 and divide that by 360. That gives us a sector area of 177.88. Our units are centimeters, so that's centimeters squared. So the area of our shaded region has an arc of 137, or a central angle of 137, and a radius of 28. So sector over pi r squared equals the angle over 360. We don't know what the sector area is, but we know the radius is 28 squared. The degree is 137 over 360. We're going to cross multiply. When we cross multiply, we'll get a sector to equal 28 squared came out to 784 times pi times 137, and we divide that by 360. So we'll take our calculator and say 28 squared times pi times 137 and divide that by 360. We get 937.31. Those are meters squared. Now, if that number seems big to you, notice that the radius is 28. That's much larger than any of the other numbers we've seen. So, of course, that's going to be a pretty big area. For number 14, we're going to be looking for the area of circle M. We want the total area. We're given an area, but that is of the sector value. We're also given a central angle, so we're going to use the same formula, which is sector over the area of the circle. You could call that pi r squared, you could call that x, you could call that a. We're just looking for that total value, so I'm not going to write down pi r squared. We're not trying to break it apart or substitute in a number. I'm going to do it with area. The central angle of this shaded region is 165 over 365. So the sector area could be plugged in as 38.51 over the area. 165, well, I'm sorry, this says 365. That's how many days are in a year. Let's go with 360 degrees. So we'll cross multiply. We need to cross multiply both directions because the area that we're trying to solve for is on the bottom. We need to make it on the top. So I'm going to take the 3851 times that by 360, equal that to the area times 165. Divide by 165. So the area of this circle is 3851 times 360, and we divide that by 165. 8402. The units in this case, we could tell by the area here that it was 3851 meters squared, so we would still have meters squared. 65 degrees is less than half the whole circle, so 84 is, well, 38 is less than half of 84. Here's number 15. We have a sector area that's 5687. We don't seem to have the central angle that represents that, but we do have 50 on the outside of that. And we're looking for the area of the whole circle. So we're going to take 360 and subtract the 50 to get 310. So now we'll use our sector area formula, which is the sector over the area equals the angle over 360. Well, the sector is 5687. We're looking for the area of the circle. Our angle is 310. We'll cross multiply to get 5687 times 360 to equal 310 times the area. We'll divide by 310. So we'll grab our calculator and take 5687 times 360 and divide that by 310. Gives us 6604. And our units were centimeters squared. Now notice, that doesn't look much bigger than what we started with, but we're dealing with a pretty large angle, so we're pretty much have the whole circle already. We just have a small portion that it's not including. So that's why they're so close. For number 16, we're trying to find the radius of circle M. Well, we don't have the radius, but we can calculate out what that would be. So we'll take sector over the area, which is pi r squared. I'm going to write pi r squared this time because I actually want to know the r. I want to break it down further. The angle over 360. Well, the sector is 1236 over pi r squared. The angle is 89 over 360. We'll cross multiply and get 12.36 times 360 to equal 89 times pi r squared. Divide by the 89, and we're left with just the pi r squared. So we'll take 12.36, times that to 360, divided by 89, and we're getting an answer of 49.99. And if we round by the next number, that will come out to be 50 even. So that's the area of the circle. Well, we want to know what the radius is. So we divide by pi to both sides. So divided by pi gives us 1591. And we can take the square root of that number. So the square root of our answer is 3.98, 3.99. And these units would be meters. For number 18, we're working with a trapezoid. We know we have a trapezoid because two sides are parallel. Two sides clearly aren't. Well, there's an area formula for a trapezoid, and that's half base 1 plus base 2 times the height. We're going to take the area of the trapezoid and subtract out half the circle. Okay, so we first need to figure out what are the bases, what are the heights, what is needed for us to calculate the circle. So the area of our trapezoid, we know that base 1 is one of the parallel sides. So we'll call base 1 equal to 16, base 2 equal to 20. The height of our trapezoid has to be perpendicular between the parallel sides. So that would still be 8. And for the circle, what we need to do to calculate its area, we need to look at the radius. And the radius, it looks like it goes from this middle line down to the edge. So if this is cut in half, this line is 8, so it's 4 and 4. So the radius is 4. So I'm going to take half of 16 plus 20 times the height, which is 8, minus, we only have half a circle, we don't have a full circle, so it's half of pi r squared. Well, that comes out to be half of 36 times 8 minus half of 16 pi. Now you could take half of the 36, you could take half of the 8. It's up to you. Don't take half of both. So half of the 36 is 18 times 8. Half of the 16 is 8. You can't subtract the 8s. So 8 times 18 is 144. 8 times pi is 2531. So 144 minus that answer gives us 118.87. Those would be inches squared. The figure that we're using is circle M. We know the area of circle M is 260.67 inches squared. The sector that's formed by KML is equal to 42 inches squared. We have a variety of questions we'll answer. Find the radius of circle M. So you got to come up with a problem-solving way to figure out what do you need to know, how are you going to calculate that. Well, I know that pi r squared is the area of the circle, and I know the circle is 260.67. So if we divide by pi, I know that r squared is going to be 82.97, and those are inches because that's a measurement, that's a length. So next we're going to take the square root of 82.97, and the square root of our answer comes out to be 9.11. And again, that would be a length let's see, we wouldn't have units on this number, sorry. Number 21, the circumference. So what is the circumference of circle M? Well, C equals 2 pi r. I know what r is. So C is going to equal 18/22 pi. And that's going to be approximately 57/24. Circumference is a length, so that would also be inches. (22), we're looking for the measurement of KL. Well, that is a degree value. So since we know the area values, we're going to take the sector area over the circle area equals the angle that we're looking for over 360. Remember that the measure of an arc is equal to its central angle. So I'm referring to the central angle, but that's also equal to the measurement of the arc. So 42 over the area of the circle, which is 2060.67, equals our angle over 360. Cross multiply to get 42 times 360. So the angle that we are working with is 42 times 360 divided by 260.67. Gives us 58. So we have 58 degrees. So the perimeter of arc LNK, that's the long way around. Okay, that's also an arc length. Either way you would phrase that, that would come out to be the same. Well, let me think about this. Perimeter, I guess, would refer to the arc length plus the two radiuses. So if the question is actually perimeter, let's stick with the actual perimeter, which would include two radiuses. So we're looking for arc length LNK plus two times the radius. So for that, we need to know what this central angle is, and that's 58. Well, the big angle we're looking for would be 360 minus that, which is 302. So 302 is our larger arc on the outside. So we're looking for arc length over the circumference of the circle, which is 2 pi r, which equals 302 over 360. So we cross multiply and see that the arc length is going to equal 1822. We've already calculated the circumference out, so that's 5724 times 302 divided by 360. And our calculator takes our 5724, times that by 302, divided by 360. So the arc length gives us 4802. And those units are in inches. That's an arc length. Now, that's the arc length, and we're going to add the two radiuses. So the perimeter is going to come around and follow the radius, follow this angle. 4802 plus 2 times 911. 4802 plus 2 times 9.11 gives us 6624, and that would also be in inches. Number 24, what is the length of KL? What is the arc length of KL? So we're going to use the arc length over the circumference, which we have figured out to be 5724, equals the angle. The angle of that shaded region is 58 over 360. So arc length of KL gives us 5724 times 58, and we divide that by 360. And arc length is a distance, so it is not squared, it's not area. Number 28, or I'm sorry, number 25. We're looking for the perimeter of the red region, which is actually the perimeter of our shaded region. That is sector KML. Well, we need to take the arc length, KL, plus 2 times the radius. So the arc length was 9.22 plus 2 times the radius, which was 911. So 9.22 plus 2 times 9.11 gives us 2744. 2744. And those units are inches. Last question. is number 30. With number 30, we start out with the circle, and we have these concentric circles. That means circles inside other circles, all with the same center. And each of these radiuses, we have 2 feet and then 2 feet extra and 2 feet more and 2 feet for the largest circle. So the inside circle has a radius of 2. The first dark one has a total radius of 4, then 6. Then the larger circle has a radius of 8. So what we're going to need to do is first we're going to take the this medium, I guess, circle with the radius of 4 and subtract the small one from the center. So I'm going to look at just this picture. So I'm going to take the large circle, which is pi r is 4 squared, and I'm going to subtract this inside out of the big area of the circle, which is pi 2 squared. So that gives me 16 pi minus 4 pi, which comes out to be 12 pi, which by decimal version comes out to be 3770. And those units are feet squared. That would just be the portion on the outside. So then I'll come over here to the other circle. We're looking for the much larger circle. And then we'll subtract this inner circle. So this is going to, we would have had one circle here. We would have had another circle around it. So that's where I'm looking at. So this has a radius of 6, and this has a radius of 2 more. So I'm going to take pi r, the bigger circle, we're looking for this area, pi 8 squared minus pi 6 squared. That's 64 pi minus 36 pi. So we're going to get 28 pi, which is approximately 28 times pi is 8796, and that's our feet squared. So we're going to take 12 pi and add that to the 28 pi to give us 40 pi. Which is approximately 125.66, and those are in feet squared. So that would be the total area in this picture. First we started with just the 2 inside and figured out that area. Then I took the bigger circle and figured out its shaded region, and then I added the 2 together.